Welcome to theoretical versus empirical probability. So theoretical probability refers to sort of what we would expect a probability to be in theory. Or it can also be sort of what the actual probability is. So for example, if we flip a coin, then we would expect that there is a probability of 1/2 that we get heads. So the probability of getting heads theoretically would be 1/2 or 0.5. Another option, if we roll a 6-sided die, again, reminder, a die is the cube we play, we roll. It has a dot, 2 dots, 3 dots, all the way up through 6. You roll it, right? If we roll a 6-sided die, the probability of, say, getting a 1 would be 1 out of 6. Theoretically, there's 6 sides. We assume that the die is fair. Each side has equal chance of occurring. So we should get a 1 once out of every 6 rolls, in theory. Empirical probability is what actually happens, what is observed. So in theory, when we flip a coin, if we flip the coin twice, once would be heads, once would be tails, if there's a 50-50 chance in theory. But in reality, we certainly know that we don't always get 1 heads and 1 tails if we flip a coin multiple times. So for example, let's say that we flip a coin 10 times. And let's say I'm going to use H for heads and T for tails. And let's say that we get H, H, T, H, T, 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 3, 4, 5, 6, 7, H, T, T. So this is what actually happened. If, say, I just flipped a coin 10 times, this is what we got, right? So our empirical probability, what we got, the probability of getting heads, well, we observed in that time, we flipped the coin 10 times, and we got 1, 2, 3, 4 heads out of 10. So we had 4 heads out of 10 tries. So theoretically, we would have gotten 1/2. The probability is 1/2. But in this trial, we actually got 4 out of 10, which is completely possible. And so the probability would be 0.4, or the empirical probability would be 0.4. So the question is, how are empirical probability and theoretical probability related? So empirical probability we can actually observe. It comes from collecting data and then calculating the probability just based off of what we collected. Theoretical probability we can never actually know. So empirical probability we can observe, we can collect this data. So we can observe this by collecting data. The theoretical probability we can never actually know. Right? So we don't know if a coin is absolutely fair. We can't have that guarantee, even if it is just a regular coin. But what we can do is we can find an empirical probability and then sort of estimate that that represents the theoretical probability. So what we do, and we will be doing this with lots of things in statistics, is we can run a study and find the empirical probability. And then we can use that as an estimate for the theoretical probability. Now, it turns out if we just flip a coin twice, we have three things that can happen, right? We could have no heads, we could have one head, or we could have two heads. And it's fairly likely that we might get a probability of 0 out of 2 or 2 out of 2 for heads, which is far off from our 1/2. On the other hand, if we flip a coin 100 times, then there's a better chance that we will get close to 50 out of 100 or close to 1/2 for our probability. If we flip our coin 1,000 times, there's an even better chance that we'll be close to the actual theoretical probability. So the more tries, so when it comes to coin, the more coin flips. In our example, used in the empirical probability calculation, then the better the chances are that the empirical probability is close to the theoretical probability. The empirical probability is close to the theoretical probability. Right, so that's empirical versus theoretical probability and how they are related. Again, if we wanted to say estimate the actual probability of getting a heads on a coin, it would be useful to flip a coin hundreds of times and then find the probability, empirical probability from that. Just flipping the coin twice may or may not give us something that's close to an accurate probability.